Welcome to the part demonstration of headlight intensity control with fog detection for vehicle and automatic braking system. So in this version, the main features of this project is automatically headlight on and off controlling with the help of LDR, which is used to detect the fog. Means whenever the fog was more, then the system will detect the sunlight. If the sunlight intensity is less than the threshold value, then automatically these headlights will be getting switched on. And whenever the opposite vehicle is coming near to this during night times, then the high beam light will be controlled. That has to be controlled to prevent the lighting fall on the opposite vehicle driver. So in order to make easy driving purpose, so that will be detected by this LDR sensor. There is the two LDR sensors. One is for the fog detection, another is for opposite vehicle headlight intensity detection purpose. Based on this LDR inputs, we are going to decrease the intensity of these lights, and based on the input from this LDR sensor, we are going to on and off these headlights. So these are the main headlighting purpose. And next, coming to the automatic braking, whenever the obstacle is coming near to these robots, so around less than 1 feet, that will be identified by this ultrasonic sensor to detect the obstacle, and whenever the obstacle detected less than 1 feet, then the applying of a brake on this vehicle by controlling that of power supply to this 4 DC motors. That will be done with the help of L293D motor driver. So when we switch on the gate, it start moving forward. If obstacle detects, and motor supply will be cut off as applying of the brake. And based on the opposite vehicle intensity, the headlight intensity will be controlled, not to the zero, it will be decreased nearby 30%, 100% to 30%. And based on this LDR inputs, we are going to on and off 0 to 100%. When the darkness detected, headlights on; when the lighting detected, headlights off. And controlling of this headlight intensity will be achieved with the help of this transistor board, so which is acting as a switch here to control the intensity to this headlights. And the LDR sensor 1, LDR sensor 2, and this one is the L293D motor driver, which is used to control the braking to these 4 DC motors. And the audible alert to provide audible alerts whenever the obstacle detected, and applying the brake, as well as it will provide as the audible alert through this buzzer. And all these input and output modules, like input modules are 2 LDR sensors and ultrasonic sensor. Output modules are LEDs and L293 motor driver to the motors, and next transistor board for the LEDs and buzzer board. And these are the output modules are interfaced to the PIC16F72 microcontroller. And the whole system getting power supply from this 12 volt 1 amp rechargeable battery pack. So this battery pack consists of 3 4 volt 1 amp batteries are in series. So we'll get 12 volt 1 amp DC output. So before demonstration, we should keep the battery under charging. Further, the charger will be provided. So on the transformer, then this charger will provide us the 12 volts DC output for charging purpose by taking a 230 volts input to this. Right. So when we are on the power supply to the transformer, which will step down the 230 volts AC to 12 volts of AC, and which will convert 12 volts of AC to 12 volts of DC output. So that is the charging voltage to our battery pack. So 2 charges battery pack, at least keep this for 4 to 5 hours of charging. And now you can demonstrate the project. So once we are on the power supply, the system will provide 12 volts DC input to this L293D motor driver. From there, the 5 volts is getting to the input of this one. And here we can see this. The 12 volts is input to the L293 motor driver, as well as to this 28 pin motherboard. So there we can see the 7805 voltage regulator, so which will regulate the 12 volts DC input and to the 5 volts of DC output. So once we get the 5 volts DC input to this motherboard, start reading input from the input sensors and controlling the output modules. So let us see the demonstration. So as of first, keep on moving forward direction. So whenever the obstacle detects, then automatically brake applied, as well as provide us the audible alert through the buzzer. And coming to the headlight intensity. So whenever the lighting was present on the LDR sensor, automatically the headlights will be off, irrespective of the day and irrespective of the things, irrespective of the opposite vehicle also, the headlights won't get switched on. And once the darkness detected, then based on this opposite vehicle intensity, headlight intensity, this will be controlled. You can see this. So like this, 30% to 100% of intensity will be controlled based on the opposite vehicle near to this LDR sensor. Let us check. So let us check on the floor directly. Just when we place it on the floor, right, obstacle detects automatically off, and parallelly the headlight also will be controlled. Right. Thank you.